Good day, Professor. So today I'll be walking you through my midterm presentation on social media data analytics. And for this analytics, I used the Facebook comments dataset I got from GitHub. And the goal was to perform end-to-end analytics using this analysis workflow. The first workflow I started off with was understanding the data, followed by ethics and the data model. Next, I proceeded with feature engineering, and that followed pattern mining, and next, sentiment and impact analysis, and finally, predictive modeling. So this next slide just summarizes the whole project, and it tells us that the original Facebook data set has over 1,000 comments, and after cleaning, we ended up having 964 comments. And it also tells us that majority of the comments were neutral comments, and we had over 508. And it also tells us that we had over 202 high engagement comments. So these findings are useful for triaging comments, prioritizing pages with higher impact, and identifying comments that may require customer responses. So high engagement should not be automatically treated as a positive engagement. So this next slide just shows how the presentation connects to my Google Colab notebook, which I will be sharing. And it just tells us that the PowerPoint follows the same order as the executed Colab notebook, but it doesn't necessarily show every coded cell. The notebook contains all the detailed implementation, while the slides just summarizes the important results. So the flow obviously begins with understanding the data, then responsible data design, followed by feature engineering, pattern discovery, sentiment and impact analysis, and then finally predictive modeling. So I'll switch over to the Colab page to walk you through these aspects. So I mentioned understanding the dataset. So first we have to load the dataset to be able to understand it and see its contents. And once that is done, we execute a missing values report to check for missing values. And once that is done, we proceed with the initial cleaning and core feature creations. I'll move over now to the PowerPoint to continue with the rest of the presentation. So for this next slide, I'll be talking about the dataset scope and analytical objectives. So as earlier mentioned, in this project, I used the Facebook comments dataset. So one important challenge is that the raw file was not perfect. So the likes column, for instance, was unusable, and the Facebook comments do not have fields like retweets. So because of that, the notebook creates required variables where necessary and explains the limitations. So the main measurable engagement signal is the reply activity. The objective here is to transform this comment level data into useful matrices that can support exploratory analysis, sentiment analysis, association rules, and predictive modeling. So on this next slide, I'll be talking about the various variables created. So this slide explains the most important feature engineering work, and it talks about the features we created, some of which involve engagement matrices, text and timing features, sentiment and impact features, and model target variables. So for something like text and timing features, which involves text length, word count, and sentiment and impact features, which involves sentiment polarity, and this was all done using text bulk polarity scores. This next slide talks about responsible handling and dimensional structure. So this slide connects the technical analysis to responsible analysis. So social media data may be public, but it still needs careful handling because comments can reflect user experiences, complaints, and sometimes even user opinions. So the analysis involves this analysis avoids exposing individual users, reports, results, and treats sentiment as an estimate rather than like absolute truth. So this slide just shows the dimensional model. The central fact table is the fact social post, which stores the measurable activities such as replies, engagement score, sentiment score, impact score, and awareness score. So everything measurable is stored here in the fact social post. The supporting dimension tables include the dim date, dim platform, dim content, and dim sentiment. So another value for separating separating the data into these tables is that the star schema separates the facts from the context. So it makes it easier for the data to be filtered, summarized, and explained. And it also supports future dashboarding because dates, sentiment groups, pages, and content features can be analyzed consistently. So I'll be moving over to the notebook to show you how the fact table and the various dim tables were created. So here we have the code to create the star schema dimensions and fact tables. And once this code is executed, we have the dim date table, we have the dim platform table, we have the dim sentiment table, we have the dim content table, and we have the fact table, which stores every numeric variable. So this next slide talks about data preparation results, and the processing stage prepared the data for visualization, association rules, and machine learning. The notebook handled missing values, removed unstable records, as I mentioned, created temporal and text-based features, and also grouped comments into low, medium, and high engagement levels. So Windsorization was used to reduce the effect of extreme engagement values, and scaling was applied to numerical features for modeling. The final engagement level distribution shows over 573 comments were low engagement comments, and 198 comments were medium engagement comments, and 202 comments were high engagement comments. So now I will be moving over to the notebook to show you some visualizations gotten from these data preparation results. So right here we have the visualizations, and these visualizations show how comment length, posting time, and date type relate to engagement in the Facebook comment data set. The scatter plot shows that most comments have low to moderate engagement, while a few shorter and medium length comments receive higher engagement scores. The hourly line chart shows that engagement changes throughout the day, with some peak hours performing better than others. Once I go down, we have the box plot that talks about text length and engagement level, and we also have the weekday versus weekend chart, which shows that the average engagement is very similar with between the weekend and weekdays. I'll move on back to the PowerPoint to continue with the rest of the presentation. For this next slide, I'll be talking about pattern discovery using association rules, and for this a prior was used to identify combinations of common behaviors that appear together more often than expected. So these visualizations we have here, like top unique association rules by lift and most frequent rules outcomes, were all gotten from the notebook. I'll switch over so you can see how they were gotten. So this code block shows the association rule visualization creation. Once it's executed, we have the outcomes where we have top unique association rules by lift, we have support versus confidence, we have lift distribution, and we have most frequent rule outcomes. And from what we can see, long comments have the most frequent row outcomes, and harsh replies and high awareness has the fewest number of rows. I'll switch back to the PowerPoint to continue with the rest of the presentation. This next slide talks about the regression model that's predicting engagement scores. So the regression model predicts the engagement scores using engineering features such as replies, text length, word count, time variables, sentiment polarities, and also comment structure. So the model produces a very high R-squared score of 0.998 with a low mean average error of 0.015 and also a low root mean squared error of 0.113. It is also important to understand why this model fits so perfectly. So the model fits the engagement score very closely because like the most important variables, which were replies and retweets, are closely related to how engagement score was created. So this is useful in demonstrating the workflow, but it should not be presented as a perfect real world data, as these variables were created by the notebook during this analysis. This next slide talks about the classification model predicting engagement level. So the classification model predicts whether each comment is low, medium, or high in engagement. So the model achieved the 100% accuracy, and the confusion metric shows that the low, medium, and high engagement categories were classified correctly. So this looks very strong, but again, it should be interpreted with caution, like I earlier mentioned. So the engagement level categories were derived from engagement score, and the model also uses variable closely connected to that score. So the model is useful for showing full classification workflow, but should not be presented as a perfect real-world prediction, as these values were deduced by the notebook. And moving to the notebook, we see how the predictive analysis was carried out and how the regression model and the classification model were produced. So after executing, we have the regression model evaluation, where we have the mean average error, we have the root mean squared error, and we also have the actual predicted engagement score, where we have the perfect fit line. As I earlier mentioned, these were all values generated by the notebook, so it should not be confused for real world analysis. And we also have top regression feature importance. This next slide talks about the sentiment analysis, and from what we can see, shows that neutral comments are the largest sentiment group, as we can see from this visualization gotten from the notebook. And neutral comments are the largest group with over 508 comments, followed by 305 positive and 151 negative comments. So this means that many comments are informational, service related, or unclear rather than strongly emotional. And an interpretation gotten from this can be that negative comments are fewer, but they show a higher engagement range. This is important because complaints can attract attention even when they are not the largest sentiment category. So the word cloud shows frequent terms such as account, service, phone, month, customer, business, Verizon, and billing related language. These words indicate that many comments are connected to customer service and user experience issues. And in conclusion, the project demonstrates a complete social media analytics workflow using a Facebook comments dataset, and the analysis moved from raw data cleaning to feature engineering to ethical data handling, where we also had star schema design, sentiment analysis, association rules, and predictive modeling, followed by final business recommendations. So